Hi guys, I'm going to try to give you notes on the phases of the moon using our rotation model here. I apologize for my video setup. I've got some boxes and paper towels holding the iPad up since my document camera doesn't work correctly anymore. So we should have cut these out, glued these in to model the orbit of the moon around the Earth. So we have our Earth in the center. We are in North America. So we're about right there. So I tried to put that at the top of the diagram because when we're looking at this diagram, what we see from Earth is going to be what's on the top here. So every 29.5 days, the moon orbits the Earth counterclockwise. So this way, we need to respect those arrows. So over here on the side, I want to write that down. The lunar cycle takes 29.5 days. And so we break that down into quarters. So we have the first quarter, the second quarter, the third quarter, and then back all the way around. And each one of those quarters takes about 1 week. Okay, about 1 week per quarter. So the very first day of the lunar cycle, we count from this very first position. And one of the important things to realize is that you can only see half of a sphere at one time. Just like if you're looking at someone's face, you can't see the back of their head. When we are looking at the moon, we cannot see the back side of the moon. So what I have here is a Post-it note that I'm going to use to represent the portion of the moon that is invisible from Earth. We can never see it because it's on the far side. The other thing I want to notice for you, point out to you so that you can notice before I do that, is this is not 8 different moons. This is one moon in 8 different positions, but you should notice they all share something in common. They all have half of the moon lighted and the other half dark. So if you look, each of these is half lit and half dark. The side that is nearest to the sun's rays is going to be the side that has the light. The other side is going to be dark. Just like day and night on the Earth, the moon has a day and night cycle like that, so half lighted, half dark. But in position 1, we can't see any of that lighted portion. Because of that, the moon we see is basically completely in shadow, completely dark. In fact, most people don't actually see it. So we call this the new moon. This is when it is completely gone from our view and when the cycle begins again. So we call that the new moon. Now, let's take a highlighter to represent this blue Post-it note. And I'm going to shade the portion of the moon that we can't see blue to remind us that that is the side that is far from us, and so we can't see it. What if we were in the exact opposite position? What if the sun's rays were coming from below, behind the Earth in this case? Then we wouldn't be able to see this portion of the moon. So the dark side of the moon would be completely on the far side. So the entire side that was visible to us would be illuminated by the sun's rays. So the side we see from Earth is going to be completely lighted. We would call this the full moon because it is fully lighted. All right. Let's rotate our moon counterclockwise so that the sun's rays are coming from the right-hand side. Let's repeat that process where we cover the far side of the moon that we can't see with our Post-it. On this position, there is half the visible side of the moon that's in shadow, but half is going to be illuminated. So when we see this moon outside, sometimes we call this the half moon, but because it is actually 1/4 of the way through the moon's cycle, we call it the quarter moon, and it's the first quarter because if we start at the new moon and work our way counterclockwise, this is the first quarter. We have 1/4 of the cycle complete. So if you struggle to remember that part about going around a quarter turn, you can also look at this as a fraction circle, and 1/4 of the moon is illuminated and visible from Earth, so that's our first quarter moon. Now, hopefully we'll begin to see some patterns emerge. So let's go and look at, well, we'll turn counterclockwise so we're being the right direction. Let's look at number 7. This moon is also a quarter moon, but on this one, the lighted side is going to be on the left-hand side. This one is going to be our third quarter. We've gone through the first quarter. Technically, the second quarter is our full moon, and so now this is our third quarter moon. We can see the lighted side is on the left, the darkened side is on the right. So if you notice, position 3 and position 7, they look very similar. The difference is that they are opposites. Okay, so now we've got the new moon, the first quarter, the full moon, the third quarter. We'll make our way back around. I want you to notice something. When we're talking about what the view of the moon from Earth is going to be like, it's determined by the angles of the sun, the earth, and the moon relative to each other. So imagine there is a line coming from the sun that stops at the earth, like you've connected them with a string. If we connect that line to the moon, we formed a right angle. Anytime there is a right angle formed by this sun, earth, moon system, you're going to get a quarter moon. Notice you got a right angle on that side for the third quarter as well. If they line up in a straight line or a straight angle, 180 degrees or 0 degrees, that's going to be a new moon or a full moon. So let's look at these other positions. What kind of angle do I form if I connect it to the moon in position 2? That's an acute angle. That acute angle, that smaller angle, is going to result in a smaller visible moon. So let's see how that plays out. If we turn it, sorry, I don't have to turn my book, I can turn my model. Put the 2 at the top. We will cover the part that's not visible from Earth. Again, it's the far side. And if we draw a line across here, what you'll notice is that the illuminated portion of the moon is very small, and the part that you see that is in shadow is very large. Most of the lighted side of the moon is towards the back, in the far side where we can't see it. Because of that, you're going to get a visible moon from Earth that has a small amount of light on the right-hand side, with the larger portion of the moon being in shadow. The other position that forms an acute angle is going to be position 8. So this is going to be also a crescent moon, also a small portion of the moon lighted, but it's going to be the opposite side because we are on the opposite side of our orbit. So draw that line there. The small sliver of moon we can see is on the left-hand side. And as you'll notice, position 2 and position 8 look very similar. They're just mirror images of each other. They're flipped. All right. The other option for an angle that can be formed is with the sun and the moon coming together to make an obtuse angle. This large angle formed by the sun, earth, and moon is going to lead to a large portion of the lighted side of the moon being visible. So for position 4, we have an obtuse angle formed by the sun, the earth, and this moon. The far side is covered. We'll draw our line. And you can see that the largest portion of the visible side of the moon is illuminated. And we call those large illuminated moons that aren't quite full the gibbous moon. So this is going to be our waxing gibbous because we're on the side getting larger every night on its way to being full. So now we've got here our new our waxing crescent, our first quarter, and now we're putting together our waxing gibbous. On the other side, because we've noticed our pattern, we're going to have our full moon after that. It's going to start getting smaller again. The visible part of the moon will be mostly lighted, but not fully lighted. But because it is waning, the lighted side will be on the left. You can compare these to your phase, the model you have on page 16 in your notebook, or right beside this in your notebook, where we have drawn the circles to show what the moon looks like from Earth. You should be able to recognize these phases now. So we have our waning gibbous, our third quarter, our waning crescent. Up here on these arrows, because this is the waxing side, we're going to write waxing. And over here is our waning side, so we'll write waning. And just as a reminder, at the bottom here, I want to make a key so that we remember what our colors are for. So our blue and our yellow highlighter represent the portions of the moon that we can't see and that we can see. So the blue is the far side of the moon. It is not visible from Earth. And the yellow side is illuminated. That's the fancy science word for has the sun shining on it so we can see its light. And it's visible from Earth. Remember, the moon is always 50% illuminated. There's always half of the moon being illuminated, but only this yellow portion is visible from Earth. The far side can be dark or it can be illuminated, but if it's on the far side, it doesn't matter because we can't see it.